Okay, so I'm constructing the Symmedian point of this triangle. In navigation, my purple lines here would be lines of position. And I'm using this pair of compasses. First of all, I bisect the sides of the triangle. I can strike any arc there that's as long as it's more than half the length of the triangle. And joining those intersection of those arcs gives me the midpoint of that edge. I need to bisect two of the lines. So I'll choose these two. So my camera's here on a flexible stalk, but so what happens if I bash it? Hope it doesn't make you seasick with the wobbles. Maybe I should have done this with a chart table. Let's see. Okay, so there's the midpoint of that side. And so next I'm going to draw the median lines. The median lines drawing the vertex of the triangle to the midpoint of the opposite side. I could actually do all three. I mean, you don't need to, but it's a useful little check to do that, and I'll just see if that works actually, because of course it should. The median should go through the same point. The midpoint, the point where the three medians converge is the centroid of the triangle, so it goes through that. Okay, so that's pretty good. Okay, so the next thing I need is the angle bisectors, and again I can choose any two, or I can do all three just for a check. These compasses have a quick release as well as a fine adjustment, and to bisect this angle I've just struck an arc there. I can choose any arc, but usually a bigger one is more accurate, provided it stays on the paper. And in this case, we see that the angle bisector is quite close to this one to the median line. Very close, in fact. Okay, so now I'll try bisecting this one. Right, so I'm using blue for the angle bisectors today. Yeah, that's the angle bisector. You see it looks pretty good, like half the angle. Okay, so now I'm bisecting this one. I've chosen an obtuse triangle. In a sense, most triangles are obtuse. If you just choose a triangle at random. If I've gone too close to the edge of the paper like that, I can actually bisect the angle on the inside of the arc if that's more convenient. I mean, you don't need to cross two places, but you just need it so that you have to be careful where it goes. That's the arc. So that should be the bisector, which is half this obtuse angle. And of course, as we expect, up to the accuracy of my drawing at least, the angle bisectors also meet at a point. It's like the lines all want to be fair, so you draw them with for each side, and there's nothing special about the choice of each side. So you can use any two sides, and the third one's just a check. Okay, so the next thing that I do is construct the Symmedian lines. So to get the Symmedian lines, I reflect the median line in the angle bisector, and just have to be careful to get that the right way round. As a rule, though, your Symmedian point will end up closer to the shortest side, so it gives you a bit of a check on it. So I'm measuring this angle on this arc I already have out the other side, and in other words, I'm reflecting the median line in the angle bisector, and that's a Symmedian line. Symmetric median, I suppose. There's my Symmedian line. Okay, so I could choose this one, but I mean, it's a little bit tricky because it's so close. So in this case, I'm going to choose this one. Let's use the fine adjustment there. So it's both practice and care makes it precise, but of course navigation, we don't really need it that precise. You could almost, just gain experience of where it goes, and then so that now is the Symmedian point. And if I wanted to just to do the other one, the other Symmedian line, I would reflect that. Oh, sorry, and measure on the arc. That's a mistake to make there. So measure that on the arc, the same distance either side, and then I suppose if I drew that line there, it will also intersect at the Symmedian point K. So that's the other Symmedian line. So now we have the Symmedian point. That's the most probable position under some fairly safe assumptions in navigation. It's the point that minimizes the squared distance to each of the purple lines. And you note, it's interesting that in a case of a triangle like this, it's really quite close to the shortest side.